So we have been working with this travel record application that allows us to save some posts. And currently in this scenario, it is working just fine because we have a little amount of posts. So making the request to the internet is actually very easy. It doesn't take that much time and we get the response back very quickly. But what does not happen in this case is that we are both not able to read these elements unless we have internet connection, and of course we are not able to insert new items unless there is an internet connection. So during the next few lectures we're going to talk about how we can implement offline sync functionality into this application. By this I simply mean that all of these items will be readily available in the local storage, a SQLite database to be precise, so we can read these elements even when there is no internet connection. In addition to this, we could also be saving elements into the local database, and eventually when the internet is back or when the user opens the application again, if there is internet, the sync will happen. All of the elements will be saved locally and just uploaded to the cloud once there is an internet connection. Now in our application, maybe this is not the best idea because we still need internet connection to get nearby elements, nearby venues, but I can definitely think about a lot of many different scenarios where this would be very useful. So during this lecture, we're going to start by preparing our application so it can eventually sync this code between an offline SQLite database and an online, of course, cloud database, SQL database that we have on Azure. We are still going to be using the exact same Azure database, by the way. So the implementation is basically going to allow us to save all of the information that is on the Azure Cloud Database, or actually, in this case, not all of the information, only the information about the current user, and we will be able to sync this offline database with the cloud database when we want if there is internet connection. So let's start by going to our solution. And in the solution, we're going to need to add one new Nuje package that is going to be responsible for this syncing. And it is going to be also adding some SQLite database functionality to our application. We have used SQLite databases before, so your applications probably in the references already have SQLite packages. But if there weren't any of them, this particular Nuje package is also going to add the necessary packages to both Android and iOS. So let's just right-click on the solution and select Manage Nuje Packages for Solution. If you are on Visual Studio for Mac, by the way, remember that this is something that you would have to do project by project. There is no way to manage the Nuje packages for the entire solution. You would just have to do this one by one. But either way, what you want to search for is the Microsoft.Azure.Mobile.Client.SQLite storage package. Simply select it, select all of the projects inside of your solution, and select Install. After accepting any license agreements and letting it just install, you should find inside of your projects a new Microsoft.Azure.Mobile.Client.SQLite store package, of course. Now, this package is the one that will contain a couple of very useful classes and interfaces that we will have to use. The first step that we will have to do is navigate to the app.saml.cs file. Here, we have already created the mobile service client that is pointing to our mobile application, the mobile app service that we have on Azure. In this class, we will have to do very important things, and that is to define the tables that we will have to be using, and we will have to initialize the SQLite database. So this is the very first step and the most important one. So right here, after defining the mobile service, I will be defining one single table, the posts table. And this is going to be a public static variable that is going to be of type I mobile service sync table. And it's going to be of type post, which of course is already a class that we have. And this is going to be called posts table. Of course, to be able to use this interface, we will have to add a using directive to a namespace that we have recently added that is coming directly from the package, that is Microsoft.windows-azure.mobileservice.sync. And this particular table now is the one that we will have to eventually use to make any requests to the database. And it is going to be smart enough to know that it has to make the requests first to the local database that we are about to set up, and later, if we are going to be syncing, this table is the one that will have to contain either to post or to read elements to or from the SQLite database. So basically, this is now going to be the interface between our application and the database, either the local SQLite database or eventually when we sync the SQL database that we have on Azure. So let's move forward on to making sure that this table is ready. We have already an app constructor that is receiving the database collection from when we were using SQLite. We are going to be using these again. We're going to be needing to set the database location because of course we are now going to be using SQLite again to save the elements locally. So what I am going to do is define a store variable. This is simply going to be the local storage and is going to be equal to a new mobile service SQLite store object. And again, this is a class that exists on the namespace that we have to add. In this case, Microsoft.windows-azure.mobileservices.SQLite store. So let's add that namespace. And this class, its constructor, is going to be requiring the offline path where the SQLite database is going to be stored. And of course, we already have that in the form of the database location. And I'm missing a new keyword right here. So in case you have forgotten, this database location is coming directly from, in the case of Android, the main activity. When we are calling the app constructor, we are already passing the full path, which is simply combining a database name and a folder path. So we are already passing this path, this file, the location of the SQLite database, to the app class. And in the case of iOS, this is happening inside of the app delegate. So we are also calling the app constructor, and we are also creating a string from a database name and a folder path, just in case you have forgotten. So this precise location is the one that we are going to be setting to the mobile service SQLite store variable. Once we have this variable, now we can use it to define tables inside of the SQLite database. So we will have to define that post table that will be holding the posts, of course. So from the store variable, we will be able to call the define table method, and we can use the generic method in here, pass the type of the table that we want, and simply call the method like this. And that's it. By now, the SQLite database now contains a post table where we can now start to insert new elements, but that is for a different lecture. Right now, the last thing that we're going to do is make sure that we initialize a sync context that will allow the database precisely to know how it is going to be synced with the local database. So to be able to do that, we are going to be using the mobile service that we have defined. So this is functionality that was already there before we started looking into this local syncing. But we needed this store to be able to implement it. So the mobile service already had a sync context. The sync context is precisely going to establish how or where is the cloud database going to be synced to in the local environment. So the sync context will simply have to be initialized. And the initialize async method, notice, is going to request a mobile service local store. And in our case, the mobile service local store is referring to this mobile service SQLite store that we have just created. So all we have to do is pass the store variable. And now the mobile service, which we have already been using a lot, is going to know how and where is it going to be synced to locally. Finally, let's just get the table ready. We have already defined the posts table. And the posts table is going to be equal to something that is already in the mobile service. So from the mobile service, we're simply going to be getting the table, but not as we are used to. We are going to be getting the table in a different way through the get sync table. This different method is going to allow us to get the same table, but it is also going to make sure that we will first be reading from the local storage, and if needed, and actually if possible, read from the cloud storage. So of course, the table that we want to read is the post table. And that's it. We have already prepared our application to start offline synchronization. So we have created, or actually added first, a new J package. So we can create a new offline sync table. And to that sync table, we are going to be getting the same table that we have used, but in a different format. Previously having prepared the offline table, which is going to be a SQLite database. In the next lecture, we're going to start to actually make requests in a different way, so we know that we are now going to be using the offline database as well.